In this section of the course, we will discuss AWS pricing models, some pricing tools, and lastly, AWS support options. This slide shows some of the ways customers can pay for AWS services. Let's dive a bit deeper into each one of the topics shown. One of the many advantages of AWS is the pay-as-you-go pricing. In the on-prem world, there was a risk of over-provisioning capacity or under-provisioning capacity. With the cloud, customers pay for resources as they consume them. This removes the headache of capacity planning and allows customers to focus on their core business. It is similar to how consumers flip a switch to turn on lights in their home and the power company sends electricity. With certain services like EC2 and RDS, customers can invest in reserved capacity for those times when their workloads are long-running, known and predictable. There are a few payment options available to customers which are all upfront, partial upfront, and no upfront payments. The biggest advantages to customers is if they reserve their capacity between 1 to 3 years, they receive a discount over the on-demand price of up to 75% depending on the payment method they choose. With AWS, customers get automatic volume-based discounts for certain services. An example of this is S3, Simple Storage Service, which uses tiered pricing. What this means is that the more customers use, the less they pay per GB a month. Another example of automatic volume-based discounts is data transfer out of an AWS region. The more data customers send out of a region, the less they pay per GB a month. There are 3 fundamental pricing concepts for AWS services. For compute resources, they are billed by the second for Amazon Linux OS and Ubuntu, and per hour for Windows OS. Note that any operating system, such as Red Hat Linux, which requires a license, is also billed for by the hour. Storage costs are relatively straightforward and typically charged per GB provisioned. Generally speaking, any data transfer into AWS, there is no charge. There is a charge for outbound data transfer, and the charge is typically done on a per GB basis. We recommend consulting the AWS documentation for the most up-to-date information on pricing per service per region. Different services are priced differently. Let's dive into some of the services listed to see how pricing works. With EC2, there are 4 purchase types. The first is on-demand. This is the default option if customers spin up EC2 instances or virtual machines. As explained earlier, the pricing is done on a per second or per hour basis, depending on the OS being used. The second type is reserved instances. Customers can receive up to 75% discount over the on-demand price when they commit for a 1 to 3 year period. The third option is dedicated hosts. These are physical servers dedicated to customers. They are typically used when customers want to bring your own license into AWS. The fourth option is spot instances. Customers can pay for spare AWS capacity and receive up to 90% discount over the on-demand price. This is a great option to gain access to large amounts of capacity at a heavily discounted cost. In this demo, we will visually explain what spot instances are. Here we have a basic graph to illustrate example compute capacity in an availability zone. Along the x-axis, we have time, and on the y-axis, we have capacity. Capacity planning for reserved instances is fairly simple. Customers commit for 1 to 3 years and receive up to 75% savings over on-demand. In the graph, reserved instance capacity is growing at a steady rate. The on-demand instance usage is determined by AWS customers. Usage will go up and down based on customer demand, and this is illustrated in the graph. Provision capacity is the amount of compute capacity within the example availability zone. Here we have highlighted the spare unused capacity. Customers can enter their max price for spare capacity in the spot market. AWS controls the spot price based on spare capacity in the availability zone. Spot instances provide a steep discount of up to 90% over on demand. However, customers can lose this capacity if AWS needs the capacity back. Let's look at a scenario of how this works. In scenario 1, there is a lot of spare capacity. Let's assume the instance we want in spot is normally $1 in on-demand. Customer launches a spot instance and enters a max price of 30 cents. The current spot price is 27 cents, which means the instance launch is successful. The customer's max price exceeds the spot price, so they will get the instance at 27 cents per hour. But what happens if the spot price goes up? In scenario 2, there is less spare capacity available, so the spot price is raised to 70 cents. The spot price now exceeds the customer's max price of 30 cents. The customer is given a 2-minute warning via CloudWatch events and instance EC2 metadata URL. After 2 minutes, the instance is terminated, stopped, or hibernated, depending on the configuration the customer has set. EBS volumes are charged by a GB, provisioned a month, but price does vary depending on the type of EBS volume selected. For example, a 100 GB provisioned IOPS volume will cost more than a 100 GB general purpose volume. To back up EBS volumes, EBS snapshots are used and stored in S3. Pricing for snapshots is charged by space consumed in S3. There is also a charge if an EBS snapshot is copied across regions. Lastly, don't forget the data transfer out aspect. If your application transfers a lot of data outbound to the internet, there is a charge for this. S3 pricing is determined by 3 factors. First is storage. The amount of storage used will change the price as well as the storage type. For example, S3 standard storage costs slightly more than the infrequent access storage. Second is the number of requests and type. For example, there is a charge for a GET, PUT, and copy request. Third is data transfer out. Any data transferred out of the region from S3 incurs a charge. There are AWS services that are free of charge: Amazon VPC, Elastic Beanstalk, Autoscaling, AWS CloudFormation, and AWS IAM. While there is no charge for the service, note that there is a charge for any resource spun up with these services. For example, if Autoscaling starts new EC2 instances, there is a charge for the EC2 instance. The AWS free tier allows customers to get hands-on experience with AWS for 12 months at no cost. Simply sign up for an AWS account, view the tutorials on our site, then go build on AWS. The free tier is scoped to specific resources, so do a search for the AWS free tier to see which resources are eligible. The AWS Simple Monthly Calculator is a tool which can be used to estimate cost in AWS. You specify the region you want to run your workload in, select the services you wish to consume, such as EC2, S3, and the calculator will provide an estimate of the AWS charges per month. The AWS Cost Explorer is a tool that can be used to analyze AWS expenditure. This tool can also forecast what the expected spend is based on the current usage of AWS services. Trusted Advisor is another tool provided to customers from the AWS console. I always mention in my classes that it is like having an AWS expert sitting at your desk to help you determine if AWS best practices are being followed in the AWS account. There are a number of checks that are performed around cost, performance, security, fault tolerance, and service limits. The tool will highlight problem areas and provide recommendations to fix the issues, as well as helpful documentation links to resolve identified issues. Here is an overview of the AWS support plans customers can subscribe to. The basic plan is free of charge and offers support for account and billing questions. As customers go up in the support plans, they unlock access to more support options and tooling. For example, under the Enterprise Support Plan, customers get a dedicated technical account manager, solution architects, infrastructure event management, as well as other services and features. My AWS journey started in AWS support as an EC2 Windows engineer. I can honestly say the premium support team is really customer obsessed, and we always work with customers to help resolve their issues. The Well-Architected Framework is a guide for designing infrastructure in the cloud according to AWS best practices. The framework was developed after reviewing thousands of customers' architectures on AWS. It is not a blueprint for architectures, but rather provides a consistent approach for evaluating architectures. The framework assesses architectures by asking customers a series of questions across 5 well-architected pillars. These questions assist customers in determining if they are well-architected in the AWS cloud. The 5 pillars of the framework are operational excellence. This looks at the ability to run and monitor systems to deliver business value and continually improve supporting process and procedures. Some of the design principles are perform operations as code, anticipate failure, and learn from failures. Security. This pillar focuses on the ability to protect information, systems, and assets while delivering business value through risk assessments and mitigation strategies. Some of the design principles used here include strong identity foundation, traceability, security at all layers, automation of security, and protect data at rest and in transit. Reliability. This pillar focuses on the ability of a system to recover from infrastructure or service disruptions. Some design principles here include test recovery procedures, automatically recover from failure, scale horizontally, and manage change in automation. Performance efficiency. This pillar focuses on the ability to use compute resources efficiently. Some of the design principles are to democratize advanced technologies, develop serverless architectures, and enable experimentation. Cost optimization. This pillar focuses on the ability to reduce underutilized services or suboptimal resources. Here, the focus is on the use of managed services, adopting a consumption model, measuring overall efficiency, and analyzing expenditure. This is an example of a reference architecture which focuses on the reliability pillar of the well-architected framework. This is a typical 3-tier web architecture that is made highly available by using the Elastic Load Balancer service. If a web server goes down or an availability zone, the load balancer can distribute load to the healthy backend instance to ensure uptime for the web application. By inserting a load balancer into this architecture, we make the application highly available and resilient from single points of failure. Here is another example of architecture that builds on the previous basic 3-tier web application. Let's walk through this together following each of the numbers in this diagram. Number 1. Users' DNS requests are serviced by Amazon Route 53. This is a highly available DNS service that runs in our AWS Edge locations around the world. Number 2. CloudFront is an AWS content distribution network which can cache objects closer to the end user to reduce latency. This service also leverages our edge locations around the world. Number 3. Any static content from the site is stored in S3, a highly durable storage infrastructure, which means we do not have to consume compute and storage resources on our EC2 instances. Number 4. HTTP requests are first handled by the Elastic Load Balancing service, which automatically distributes incoming traffic to our EC2 instances across availability zones. Number 5. The EC2 web servers process the web traffic. Customers can customize the applications deployed on their EC2 instance and can pre-bake their Amazon machine images, AMIs, to spin up more instances of the same application. Number 6. The EC2 instances are deployed in an EC2 auto-scaling group, which can intelligently scale out, add more EC2 instances, or scale in, remove EC2 instances, based on load coming into your web application. This is a way to give your application the compute it needs to service your requests under heavy load and then remove that compute to save on cost when the load goes down. Number 7. An Amazon RDS database is used in a multi-AZ deployment to give the database layer redundancy. Data is automatically replicated between a master and standby database instance managed by AWS. The entire architecture has been designed with high availability, redundancy, and security in mind. Thanks for watching this online awesome day. I hope it has been informative and you have learned something new and are keen to go out and build on AWS. AWS training gives customers the skills needed for success. There are 4 AWS value propositions where AWS training contributes to customer success. Let's look closer at these value propositions. Faster time to market. Comprehensive AWS training helped customers adopt AWS Cloud 80% faster than customers who did not have a formal training program. Increased profitability. AWS training increases staff productivity by a factor of 4.7, accelerating their ability to deploy the right AWS service quickly, securely, and with fewer problems and issues. Lower business risk. AWS training helps you avoid common pitfalls and problems by a factor of 4.4, helping you avoid these and other related problems. Increase employee engagement. According to a global knowledge report, improving job satisfaction through AWS training increases employee satisfaction by 30%, and satisfied employees are 5 times less likely to seek a new job. We have 3 pillars to our offerings, and we combine all 3 in a comprehensive training program. Digital training. Our free digital training library consists of over 400 courses which are available on demand, anytime, anywhere, so you can learn at your own pace. The training is also very cost effective since there is no charge for our digital training. Because it is developed and built by AWS experts, it is accurate, which ensures you use and deploy AWS services in the right way. To consume this digital training, browse to the website aws.training today. Classroom training is often the most effective and cost-effective way to accelerate your team's AWS skills. We have over 20 classroom courses which are taught by accredited instructors who teach skills relevant in the real world. AWS certifications. AWS certification help you identify those you want to entrust with your AWS projects and cloud initiatives. The 2018 Global Knowledge Report shows that AWS certified professionals solve problems faster and are more productive, which gets you to your business goals faster and more reliably. AWS learning paths are designed to help you build and advance your skills in a specific technical area. Whether it's a role-based, specialty, or solution-based path, AWS learning paths have you covered. We have over 400 courses to help you build new cloud skills. As mentioned, you can access the free on-demand digital courses on our website aws.training. If classroom training is your preferred learning method, we offer AWS classroom training taught by our expert AWS instructors. There are currently 11 available AWS certifications. They range from the foundational certification, Cloud Practitioner, which covers foundational concepts, to specialty exams such as machine learning, which dives deep into that specific technology on AWS. Preparation is key when preparing for your AWS certification. You can access the website on the slide. It details customized preparation steps based on the selected exam. For example, it will recommend classroom training, white papers to review, practice exams, and so on.